Welcome to our YouTube channel. In this video, we are going to talk about equilibrium in physics. But before we start, don't forget to hit the like button and subscribe to our channel for more videos. Let's dive into equilibrium. Now, what do we mean when we say equilibrium? What we mean when we are talking about equilibrium is a situation where we have an object, and that object has got forces which are balanced. Then we are going to say that object is at equilibrium. In this case, there are a number of situations that we are going to talk about under this topic of physics. The first one, we'll talk about the equilibrium of an object on the horizontal plane. So we'll talk about horizontal plane. Okay, now horizontal plane means that, for example, we have the surface which is like this. It can be a table, it can be the ground itself, and here is an object. This object can be a vehicle or a stone or anything, but there is an object. Now, this object can neither move to any of these directions. It means that all the forces are balanced. In this case, what forces are they? Number one, we need to understand to say this object has got a center of mass where all the masses or all the forces of that object is at. In this case, for this object to remain stationary, it means that the force which was trying to move it forward, the force which was trying to move it backwards, the force which is trying to move it downwards, and the force which is trying to move it upwards are all balanced. Now, what are these forces? The force which is pulling this object going upwards is called normal force. So it is normal force. The force which is trying to move this object forward is the force which is applied to an object. So we can just put this as F. Then we have the force which is opposing the motion of this object, which is the force of what? Friction. Now, this force of friction can sometimes be represented as Fr. So don't get confused when you find some books using Fr, some using Fk. Then we also have got this force which is trying to pull this object downwards. This force is called the force due to gravity, which is called weight. In this case, let's go ahead and see what we need to understand. Since we have this movement of forces which are opposing each other, we have the force of friction opposing the force which is trying to move the object forward. We also have the normal force which is opposing the weight being equal to 0. Therefore, we are going to say, to make this thing easy, we have the force in the x-axis and the force which is in the y-axis. Okay, let's begin with the forces in the x-axis. The forces in the x-axis, we have this force which is opposing the motion of this force. Therefore, for this to happen, since we know that when we add these two forces, obviously the answer is 0. It means that these forces, one is going to be positive, the other one is going to be negative. Now let's say this force which is this side is positive, then this side is negative. Therefore, we'll go ahead and say this force plus, because we are adding, plus the force of friction which is negative. So it will be negative Fk is equal to 0. So these forces are equal to 0. Therefore, we'll go ahead and make this force to be the subject of the formula, where we're going to have F is equal to Fk. So the force, the forward force is equal to the force of friction. That is what we have. That is what we have. Now, in this case, we know that this forward force can be found by forward force is equal to mass times the acceleration. That is what we have. Then the force of friction, which is Fk, is always equal to mu multiplied by the normal force. Now, we can do the replacement where there is F, we put Ma. So we can say Ma is equal to mu multiplied by normal force. This is the equation that we have as equation number 1 as our x-axis forces. Let's go ahead and see what we have in the y-axis. In the y-axis, we have this force and this force. One is positive, the other one is negative. Let us assume that this force, which is here pulling downwards, is positive, then this one is negative. Therefore, we are going to have weight plus the negative of the normal force, which is equal to 0, because they add up to 0. They cancel each other. Therefore, we can go ahead and make weight the subject to the formula, where we are going to have weight being equal to normal force. This is what we have. In this case, we know that weight can be calculated as the mass times the acceleration due to gravity. Therefore, we can go ahead and replace where there is the weight by mg. Then we are going to have our formula as mg is equal to normal force. Then we can go back to our first equation. So this is equation number 2. In the first equation, remember we said force, which is the forward force, is equal to mu times the normal force. In this case, we discovered that the normal force is mg. Therefore, we can go ahead and replace normal force by mg. So we are going to have our new equation as mass multiplied by acceleration is equal to mu multiplied by, since normal force is mg, then we will replace it by mg. Therefore, if we are finding the acceleration, we can cancel out these m's. Then we are going to have our equation for acceleration as equal to mu multiplied by g. Alright, don't forget to hit the like button and subscribe to our channel. This is the first part of our videos. The second video will come and explain on the inclined plane. Thank you for watching.